Jenny Red Miles, and you are watching my video on how to divide decimals. So a couple of things. If you like this video and you want to take some of my live math classes, all you have to do is go to outschool.com, my profile, and you will see all the classes I teach. It's in the description below, and you can see that. Also, if there's a particular video that you would like me to make about a particular concept in math, just comment below. All right, so let's divide some decimals. All right, so there's some things I want to look at before we get started that are just I want us all on the same page. So first, let's look at the different parts of a decimal. So you see here, this 2 is the whole number. And then these are the decimal parts. And each one of these decimal parts is in a place value. So each one of them are in a place value. So let's look at those place values, okay? So here's a number, and we're going to label all of our place value. And our whole numbers have a place value. So these are our whole numbers. But also our decimal parts have a place value as well. And I'm going to do those in another color. These are our decimal parts. All right, so let's start with our whole numbers. And right here, the first one to the left of the decimal is our ones place. So if I was looking at this like money, I have $1,234. I would have these $4 in ones, okay? And I would have this 3 in tens. So this is our tens place. This is our hundreds place. It's hard to say this, trying to be pronounced very particularly the S versus the THS. And this is our thousand place. Okay, so think of it like money if you get stuck. This means I have 4 $1 bills. This means I have 3 $10 bills. This means I have 2 $100 bills, and they don't make a $1,000 bill, but you know, it's $1,000. So when I taught my daughter decimals and place values, I gave her play money. So that's a good way of doing that. And I might make a video of that. Okay, so let's do our decimal parts. So starting right here from the right to the decimal, it's tens. And the reason this is the tens place is because everyone always thinks this is the ones, but these have to be able to be made into a ratio using a fraction. So if this was the ones, it would have been 1/5, which if you know anything about fractions, would have reduced it down to 5 as a whole number. This isn't a whole number. Everything to this side of the decimal, to the right of the decimal, is less than 1. It's less than 1 whole thing. If I have 56 cents, because I'm just going to look at the money part, I have less than $1. So we have to go to the next thing, and if I made this a fraction, it would be 5/10, which is less than 1 whole thing. That's actually 50 cents there. So it's a half. It's going to reduce down to a half. So that is why we don't start with the ones place, a oneth place, because it would give us a whole number, okay? So the next one, just working our way, we're just keep adding a factor of 0, and I'll show you what that looks like here in a minute. This is the hundredths place, the thousandths place, and going a little bit more, 10 thousandths. Let me give you the factor value for all of these. So for on this side, it would be whatever is in that place value over 10. The next one would be whatever's in that place value over 100. And whatever's in this one would be 1,000. Look, I just keep adding a 0. That's because the base for the decimal system is a factor of 10. So each one is being multiplied by a factor of 10. And that is just our base system. Okay, same as the metric system, it's a base 10. But then we have other systems like base 12 for inches to feet, and there's a bunch, binaries to base system. That's just this base system. Okay, now there are a couple other things we need to know before we can dive into dividing decimals. All right, so the last thing we need to know before we can start dividing decimals is the part of a division problem. This gets a lot of people have a lot of trouble with this, so I just want to go over the different parts. So right here is your quotient. A quotient is the answer to a division problem, so you'll find it up here on the top. The dividend is what goes on the inside of a problem, and the divisor is what is being divided into your dividend. Okay, so let's look at a problem. There are a couple different ways I can write a problem. It doesn't necessarily come like this, especially in this particular video. I'm not going to ever write it like this because you can't find this symbol. All right, so the two most common ways besides this would be this way or this way. Okay, so let's label these A and B, and I'll show you where they go in our quotient, divisor, and dividend. So in this one, this is B and this is A. Okay, in both of them. So whatever comes first goes inside, and whatever comes second goes on the outside. Okay, either in a fraction or in this way. So for both of these, it would have been written like this. Okay, all right, so let's divide some decimals. All right, so here's the first decimal, 20, and 5 is being divided into it. So when I set this up, I'm going to set it up like this. Now I know these aren't decimals, okay? I just want to show you how division works, and then we're going to apply those same rules to a division problem, all right? All right, so first thing I want to do is look at a division problem with whole numbers. Remind ourselves of what's going on, model it, and then apply what we know about division to decimals. So in this one, I have 20 Skittles. So I'm going to draw out my 20 Skittles right here. And dividing means I'm going to put them in groups of 5. So 5 Skittles make a bag. So I made 4 bags of Skittles. The answer is 4. Okay, so what it does is it takes a whole number, a whole amount, and it puts it into groups. Division of decimals is different, but I want you to see how it differs. Okay, so let's look at a division problem. So in this one, I have 20 divided by 0.5. Well, that's like having 20 candy bars. Okay, 1, 2, 3. Ooh, maybe I should make these smaller. I think that would be smart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and then dividing it into 0.1 pieces is saying, because 0.1 is half, okay, it's 50 cents, which is half of $1, or it's 0.5, which converts to 1/2 as a fraction. So that 0.5 is like saying group them into half candy bars. Well, to be able to group this into half candy bars, okay, I have to cut them all in half, right? So I'm going to get out my knife and I'm going to cut all of my candy bars in half. So I'm cutting all my candy bars, and now they're in half pieces. Well, if I count all these groups up, so on and so forth, and you can cut them all up. I'm going to have 40 candy bar pieces. So grouping them into fractional parts is going to make more in this situation because I have all these whole pieces and I'm cutting them into fractional parts. I don't want the whole candy bar grouped in a group. I want half of the candy bar grouped in the group. So that means I'm breaking up all my things, okay? So now we're going to divide two decimals, okay? Well, one is going to be a whole number and one is going to be a decimal, just like the other problem. So there's some things we need to look at from the other problem. So in our other problem, it was 20 divided by 0.5. Well, we did it by modeling, right? We took our 20 candy bars, we cut them in half, we saw that we have 40 candy bar pieces. We can also do it by steps of dividing. Okay, so now I have to say how many pieces can 0.5, if I take the 20 and I divide it into 0.5 pieces, how many groups will I have? We know the answer is 40 because we just did the modeling, but from a mathematical point of view, that's hard to see. I mean, because it's 0.5, I can say it's being cut into half pieces, which means I'm going to have double the amount that I have, which is 40. But how do I do it when I have a problem like the one we have here, where it's 30 divided by 0.12? Well, we have to come up with a way of doing it. So people saw this pattern, and it's what we use in a lot of different areas, coming up with common denominator with fractions and working with systems of equations, and that is the rule of equivalency. And the rule of equivalency says as long as you do something to everything, it doesn't change the answer. So what we do is we multiply this by a factor of 10. All right, so let's look at factors of 10 real quick. And I'm just using an example. If I were to multiply 2 times 10, it would be 20, which is like moving the decimal place at the end of that 2 one place. If I multiply it by 100, the answer would be 200, which is like taking this decimal place and moving it 2 places. If I multiply it by 1,000, my answer is 2,000, which is like moving the decimal 3 places. So the amount of zeros the factor has is how many places it's going to move it. So let's look at our problem again. I have 20 divided by 0.5. I need to move it one place to be able to make that a whole number, something I can kind of compute better. Okay, so one place would be multiplying both numbers by 10. All right, if I multiply both of the numbers by 10, I'm going to have 200 on the inside and 5 on the outside. 5 goes into 24 times. And into 0 times. It would give me the same answer. So let's apply that idea and come up with steps for dividing. All right, so steps over here. First thing we need to do is figure out what to multiply our numbers by to make the divisor a whole number. Okay, so make divisor a whole number. Okay, so I can see 2 decimal places. Aha, I need to multiply by 100. So I'm going to multiply both numbers by 100, which is going to give me 3,000 divided by 12. Now I must set up my problem. 12 on the outside, 3,000 on the inside. Okay, now I'm going to divide and figure out what the answer is. So 12 goes into 30 twice, and that's going to be 24. Drop down my 6. 12 goes into 60 5 times. And we got to have a place value for that last one. 12 goes into 0 times. So if I take my 30 candy bars and I cut it into 0.12 pieces, which is close to 8 pieces. It's a little bit less than 8 pieces per candy bar. I'm going to get 250 candy bars, which makes sense because if we're close to 8 pieces per candy bar. Well, 8 times 3 is 24, so we're looking at 240. But this is not quite 8 pieces, okay? So the first thing we did was make the divisor a whole number, divided the numbers. Don't forget about place value, as in that place. All right, so 2 rules are not too bad, but we're going to end up adding some more as we go along for different situations, okay? So let's look at another situation. So this is when we're dividing a decimal into a whole number, all right? All right, let's look at another one. All right, in this one, we're dividing 2 decimals. So I have 0.23 of a candy bar. I don't even have 1 candy bar, and I'm going to rip that into 0.05 pieces. So let's look at how we would do this. The first step is still the same, okay? I need to make the divisor a whole number. And that's this number. And as you can see, I have 2 decimal places I need to get rid of, which means I'm multiplying by 100. Well, if I do that, my new problem is 23 divided by 5. So now, set up problem. All right, so 23 is on the inside, 5 is on the outside. Okay, and now we have a new rule. That new rule is going to be put decimal in answer. So this one doesn't have a decimal, but the decimal would be at the end of the problem. So after the 3, we have a ones place and a tens place, and then there are decimal. So 5 goes into 23 4 times, which would be 20. All right, drop down my 3. Once as I'm on the right side, and I'm going to put a little thing, once as you are on the right side of decimal, you can add zeros. And I can add as many as I want. And let me show you why, okay? Do I change the fact that I have $4 in the way I write it? No. The top one, the middle one, and the last one all say that I have $4. It's not changing anything to add zeros after the decimal in a division problem. Now, if you put numbers on both sides of those zeros, yeah, they have to be to the end of all the digits. Okay, so I'm going to add a 0. I can even put my decimal place here so I keep it straight. 5 can go into 36 times, and it went into that evenly. So I'm done. Once I'm done with the digits and I have no more remainders, I am done with dividing. Okay? All right, let's look at another situation. So let's recap just shortly. A small decimal into a large number gave us a really big answer. When I took a small decimal into a small decimal, it gave me a whole number and a decimal part, gave me 2 parts. Okay, so anytime I take a small number into a bigger number, I'm getting a bigger number out, okay, with decimals. Let's look at some other examples. So in this one, I have 2 mixed decimals. When I say mixed, I mean I have a whole number and a decimal part. Whole number, decimal part. And nothing really changes except for a little bit of fluency. So the steps are still the same. I got to figure out what to multiply this by. The divider needs 1 number out, so that would be a 10. My new problem is 21.2 divided by 15. I set up my problem. I put my decimal point in, and I'm mindful of those decimal places, and I'm going to divide until I stop having remainders. So 15 goes into 21 one time. Drop down my 2. Okay. 15 goes into 62. That's going to be 4 times, which is 60. Drop my 2. Now I'm to the right of that decimal. I can add some zeros. So 15 goes into 21 time. I can drop down another 0, as many zeros as I want. I can put at the end of this. It doesn't change anything. So 15 goes into 50. Let's see here. We can do 3 times because that would be 45. And look, it's gonna keep coming out 50. Okay. This is called a repeater, and it's given by a bar over the repeating number. Okay, so in this one, our bar is going to be above that 3. So when I give an answer, it's going to be 1.413 with a bar over it. Now let's look at this. Okay, let's recap here. All right, so I took a number, 2 numbers. The second number, the divisor, is still smaller than the dividend. Okay, and in all of our cases, when we did that, the answer turned out bigger, right? Not in this case. Our answer is in between 2.12 and 1.5. So what was different here? Well, in this one, we applied 2 different rules. Remember that first one where I did the whole numbers and we said how many times can 5 go into 20 and the answer was 4? Well, that's what's kind of going on here. I have whole number and decimal parts, which means that the whole number is being grouped in groups, as well as the decimal is being tearing up. It's doing both things. So when I say, so what I want in these situations is a number that's in between them, because I'm grouping my Skittles into bags of Skittles and I'm cutting my candy bars apart. I'm grouping into groups of 1 with my whole number of 1, and I'm tearing apart with my decimal part of 0.5. I'm doing both. So I should have like an answer that shows both. That's kind of in the middle. All right? Very good. Okay, so let's look at this fluency one more time. 5 can go into 24 times. We know that. When I multiply a small divisor into a big dividend, I should get a big answer because it's taking my 5 candy bars and it's cutting them into 0.3 pieces. It's grouping them into fractional parts. Okay, so if I were to do this one, I want to get an irrational number, but so 5 divided by 0.3 is going to give us an answer of 16 repeating 6. So yes, when I cut up my candy bars, I got a number that was bigger than both of the numbers. Now, the same thing is true when I take 2 decimals and I divide them. So let me show you what that looks like. So I ended up getting a whole number. Why? Because I'm taking that 0.56 and I'm tearing it into 2.6 pieces. So I was able to make 2 groups out of that 0.56, that word 0.26, and then there were a little bit of extra of 0.15 that didn't make a full group. All right, in the next one, I have 2.25 and I want to divide it into 3.6. Now, we didn't do one like this, so let's think about it. Actually, let's skip over it. Let's do the next one. This is one like what we did. 10.3 divided by 6.1. So I'm taking 10.3 candy bars and I'm putting them in groups of 6.1. So I'm going to be grouping 6 of my candy bars and I'm going to take 0.1 from either another candy bar or from that 0.3 candy bar I have on the side. All right, so we're tearing up some of our whole candy bars to make these 0.1s, but we're also grouping 6 of the candy bars together. So if I do that one real quick, we're going to be able to make 1.68, and I'm going to round it to 1.689. All right, so we fell kind of in the middle of these, but we got to think about what we're trying to do. We're trying to cut that 10.3 up. So now let's use this as our testing fluency question. All right. So I have 2.25 candy bars, 2 candy bars, and 0.25, which is 1/4, by the way, of another candy bar. And I want to put them in groups of 3.6. Okay, now think about this. If I have 2 candy bars and I'm part of another one, can I make a group of 3.6? Let's do the math and see. So this is my divisor. I need to multiply by a 10 to make it a whole number. So my new problem is going to look like this. Look at how much bigger this number is than this number. All right, got to put my decimal point in. 36 cannot go into 22. I'm going to put a 0 as a placeholder just so that I keep my place values straight. 36 can go into 225. Let's make a guess. I'm going to guess it can go in about 6 times. So let's go ahead and see what that is. And I think that's probably the highest we can go. And now that I'm to the right of the decimal point, I can add as many zeros as I want. And I got a feeling it can go into that 2 times. And I'm correct. And who cares if you're not correct, by the way? Sometimes I get students who are so caught up on, oh, I have to pick the right number. No, you don't. Just start guessing. Just start playing with numbers. When you play with numbers, when you guess, when you test your guess, when you do these testing fluencies, and I like to do these testing fluencies in my classes, what you do is you start creating patterns on your own. You start seeing patterns. And what you discover, you're going to memorize a lot longer than what I discover and try to tell you. All right, so 18, and this could keep going and going and going. And I'm not even going to keep going with it. I'm just going to write that as my answer because what I want you to see is no, no. What I would have done in my class is made everyone come up with a hypothesis of what would happen with that one. And I would have liked to see, but if your hypothesis is wrong, that is also correct. A hypothesis can be right or wrong. The point is to learn from it, okay? So my hypothesis would have been, I can't even make one group. My answer will be a number less than 1 because I can't even make one group. And that shows number fluency, okay? That's what we want to get to, being able to say, oh, if I'm dividing 3.6 into 2.25, I can't even make one group. I can't even divide it into one group that is 3.6. So I'm going to get an answer less than 1. Play with these numbers. Start practicing guessing before you do a division problem. It will help you, especially if you're looking at this class to help you with test taking for multiple choice tests. This is a really good skill to help you guess what the answer should be so that you don't have to go through all the math involved in finding the question to a multiple choice question. All right, I hope you like this class. If there are other topics you would like me to make videos on, please put it in the comments below, and I will do my best to get them up there. In the meantime, keep practicing that math and keep discovering new patterns every day. All right, if you like this video, please like it and subscribe so you can get more of my math videos. If you would like to take some of my live math courses, check me out on outschool.com. I have tons of math classes for pre-algebra, algebra, and on up. If you want to take some of my flex classes for all ages about math, you can check out udemy.com. Those aren't live, but you get all of my videos along with all of my worksheets and curriculum that I've made. I hope that you like my videos. Please put down in the comments anything you would like me to make a video on, and make sure you subscribe.